Alright, so seventh one that we need to simplify, x squared minus 4 over x squared minus 3x minus 10. We're multiplying now by x squared minus 25 over x minus 2. Now with multiply, the nice thing is you don't need common denominators, okay? So what you need to do is you need to factor everything that you can and then reduce your common factors. This right here is a difference of squares. So that becomes x plus 2, x minus 2. This right here, factors of negative 10 that add up to negative 3. It's going to be a negative 5 and a positive 2. Times. Here's another difference of squares. X plus 5, x minus 5. And then this does not factor. X minus 2. So we're looking, what's the same on the top and the bottom? I see x minus 2 here and an x minus 2 there. I see an x minus 5 here and an x minus 5 there. I see x plus 2 here and x plus 2 there. And so the only thing we're left over with is x plus 5. For number 8, we're given x squared minus 3x plus 2 over top x squared plus x minus 6 times x squared minus 9 over x squared minus 1. Here we're thinking of factors of positive 2 that add up to negative 3. It's going to be negative 1 and negative 2. Negative 1 times negative 2 is positive 2. Negative 1 plus negative 2 is negative 3. Factors of negative 6 that add up to positive 1. That's going to be x plus 3 and x minus 2. 3 times negative 2 is negative 6. 3 minus 2 is positive 1. Over here I see a difference of squares. X plus 3, x minus 3, and below it another difference of squares. X plus 1, x minus 1. So let's cross out what's the same, but remember they have to be on the top and the bottom. So I see an x minus 1 here, an x minus 1 there. I see an x plus 3 here, an x plus 3 there. And I see an x minus 2 here and an x minus 2 there. So the only thing we're finally left with is the x minus 3 over x plus 1. Now we need to do division. We have x squared plus 2x over x squared plus 9x plus 20. We're dividing by x squared plus 4x plus 4 over x squared plus 10x plus 25. Now we don't like dividing by fractions, so what we're going to do is we're going to change the divide to a multiply, and we're going to multiply by the reciprocal of this fraction. So this stays exactly the same, x squared plus 2x. This stays exactly the same, x squared plus 9x plus 20. Divide becomes multiply, and then flip this fraction right here. X squared plus 10x plus 25 over x squared plus 4x plus 4. Now that we set it up as multiply, we want to factor everything that we can. Now this looks different than anything we've done before. It's not a difference of squares because it's addition and not subtraction, and this is not a perfect square. It's also not a trinomial like we have been factoring. So what we're looking for is a greatest common factor. And I don't see a number that's common to both of these terms, but I do see that each one has at least an x. So we're going to factor the x from that expression. It's kind of like undistributing. and x plus 2 will be left over. Down here, factors of 20 that add up to 9, x plus 4 and x plus 5. Over here, factors of 25 that add up to 10 will be 5 and 5. And then here, factors of 4 that add up to 4 are 2 and 2. And so now we need to do some reducing. I see x plus 5 on the bottom and x plus 5 on the top. You can't cross both of them out. Only if there was another x plus 5 down here could you reduce the x plus 5 in the numerator. X plus 2 and an x plus 2 reduce, and nothing else does. And so when we write our answer, you're going to have an x and an x plus 5 left on top over x plus 4 and an x plus 2. And you're done. Okay, last division problem we're doing is number 10. We have 6 over x squared minus 2x minus 15 divided by 12 over x minus 5. Remember, if it's division, you want to automatically change that to multiply, and you're multiplying by the reciprocal. So 6 over x squared minus 2x minus 15, change to times, and then flip this. X minus 5 all over 12. You never ever flip that first fraction. Okay, so here we're factoring everything we can. 6 does not factor, but the x squared minus 2x minus 15 does. X minus 5 and x plus 3. We still have x minus 5 on top, and we got a 12 on the bottom. So when you reduce your x minus 5s right there, but then I see a 6 over 12. And I know what that fraction is. 6 over 12 is 1 over 2. So you replace the 6 with a 1, replace the 12 with a 2. And then just multiply straight across. 1 over, and then 2, x plus 3. Okay, last two problems we have to do are about complex fractions. So we have x over 3 minus 4 all over 5 plus 1 over x. Now what I do is I like to do these separately. Okay, the first one I'm going to look at is I'm going to look at this, then I'll look at the bottom, and then I'll worry about simplifying the complex fraction. So we're going to come down here. X over 3 minus 4, and I'm going to put the 4 over 1. Now I'm looking here, and just like in one of the previous examples, we have to think, what's the least number that both 3 and 1 go into? And the answer to that is 3. So we put a 3, we put a 3. I don't need to multiply this by any number because the denominator is already 3. So that's equal to x over 3 minus 12 over 3, which is equal to x minus 12 all over 3. So this right here gets replaced with x minus 12 over 3. That's the goal. You want to make one fraction in the numerator. Over here we've got 2. 1, 2. Now what we'll do is we'll deal with the 5 plus 1 over x. I'm going to write 5 as 5 over 1 plus 1 over x. Trying to think the common denominator between 1 and x. This guy needs an x over here. So we'll multiply by x on both sides. Apologize for the noise outside. Multiply by x on both sides. We'll get 5x over x plus 1 over x. And that equals 5x plus 1 all over x. And so that is what replaces your big denominator. Now we don't want that big denominator there. We don't want fractions inside fractions. So once you're at this step where you have one fraction in the numerator, one fraction in the denominator, you're going to multiply by this reciprocal. And again, where I got that from is I looked at 5x plus 1 over x, multiplied by the reciprocal, which is just x over 5x plus 1. And what's nice is that this and this reduces, this and this reduces, so our big denominator is gone. It reduced. But I've defined the laws of the universe here because I multiplied by a number in the denominator and not in the numerator. So you also have to do that. Look to see if anything reduces. In this case, this and this are not the same. X and 3 are not the same. So when you write your answer, just write the x first, then the x minus 12 over 3 and the 5x plus 1. And you're done. So we have just one more to do that's just like this. I'm going to write it down. You should try it before you look at how I do it. 8 plus x over 3 divide by 2 over x plus 2. Go ahead and hit pause, do this one, and when you push play again, you'll see if you got it correct or incorrect. So we're going to simplify this part first. That's 8 over 1 plus x over 3. I wish I had picked a better number here because we've already done 3, but that's okay. All right, again, a number that both 1 and 3 go into will be 3. So in this case, we'll have 24 over 3 plus x over 3, which is 24 plus x all over 3. So this gets replaced. Now what we'll do is we'll look at the bottom. 2 over x plus 2, and I'm going to write that as over 1. Common denominator here is going to be x, so I'll multiply by x over x over on this side. That becomes 2 over x plus 2x over x, and so that's 2 plus 2x all over x. This gets replaced, 2 plus 2x all over x. Now that we have just one fraction in the numerator, one fraction in the denominator, multiply by x over 2 plus 2x. That allows us to reduce this, here, and here. Do the same thing in the numerator, x over 2 plus 2x. X and 3 do not reduce. 24 plus x does not reduce with 2 plus 2x. So when you write your answer, write the x first, then the 24 plus x, all over the 3, and then the 2 plus 2x. And you want to box that answer up. So, happy studying, mathematicians.